So this is joint work with Sun Duan. So one problem that is very difficult but also very desirable in biomedical language processing is extracting discourse coherence relations, which are pieces of information that span multiple sentences. So this is desirable in a lot of biomedical tasks. So these include things like question answering and information extraction and document summarization. And if you think back just to Cece's talk where she mentioned problems extracting information spanning multiple sentences, this could be a potentially useful approach to that. So what do I mean by discourse coherence relations? So here's an example from biomedical text. BRCA1 gene induced significant rescue of cells in the thymus, but produced little recovery of cells in peripheral lymph node compartments. So we can break this down into two semantic arguments. The first one, induced significant rescue of cells in the thymus, and the second one, produced little recovery of cells in peripheral lymph node compartments. And these are joined by the discourse connective but. So in this case, this is a contrasting relationship signaled by the connective but. And you can imagine a lot of different kinds of relationships involving parallelism, causality, and so on. In fact, there are 31 standardly used coherence relations. This is a schema of biomedical coherence relations adapted from the schema in newspaper text. So our task is, given some biomedical document, it could be clinical notes or any other kind of biomedical document, extract the coherence relations automatically. So what kinds of features do we have available for the task? So one obvious one is this discourse connective but. However, in many cases, we don't have that luxury, and the connections are just implicit. So the problem is to identify, in this case, induced significant rescue of cells in the thymus as standing in a contrasting relationship with produced low recovery of cells in peripheral compartments. So what kinds of features can we use for a machine learning task? So one class of features that has been proposed before is grammatical syntax, so the linguistic substructure of the arguments in question. And this has been proposed in the context of newspaper text, but not biomedical text. So what does this look like? So returning to our example here, we can actually put up the linguistic parse trees for each of these arguments. So on the left side, we have induced significant rescue of cells in the thymus, and on the right side, produce low recovery of cells in peripheral compartments. So if we actually look at these parse trees a little bit more closely, we'll see that they are actually identical. Well, apparently we won't see that. They are identical. So in this case, we have identical syntax in the context of a comparison or contrasting semantic relationship. So this is an argument for syntactic structure providing some kind of useful cues to the overall semantic relationships. So what kinds of features can we use given that? Well, we can actually break these trees down into the subtrees. These are also called rules. So for example, this rule, PP goes to prep NP, could be a feature in our machine learning task. And this is the approach of Lin et al. 2009, although not in the context of biomedical text. So in terms of this project, we have two goals. So one is to evaluate the syntax feature in biomedical text for the first time. And the second is to actually develop a new feature, syntactic recurrence, that we think can improve over the basic syntax feature. And this is something that hasn't been developed in any kind of text so far. So let's take up the first sub-goal here, evaluate the syntax feature in biomedical text. So our data set is the Biomedical Discourse Relation Bank, which is a corpus of 24 full-text biomedical articles from the Genia corpus, almost 5,000 sentences, almost 6,000 annotated relations, 3,000 of which are implicit. And we're going to be focusing just on the implicit relations for this task. So given this data set, we run it through the state-of-the-art biomedical syntactic parser from McCloskey 2010. From there, we develop our features and run our machine learning algorithms, and finally output classified relations according to those 31 classes that I showed a few slides back. So for our machine learning, we use SVM, in particular SVM multi-class with 31 classes and a linear kernel. Our training set consists of 20 of the documents in the corpus, which is over 2,000 discourse relations. And the test set is the remaining 4 documents, which is about 600 discourse relations. So here are our results, and these are just for the syntax feature. So on the y-axis, I have classification accuracy with a baseline of 28%. So this is based on majority class. So if we just, if our algorithm just chose the most common class every time, it'd get 28% accuracy. And on the x-axis, I have the number of syntactic rules that we use as features in decreasing order of frequency. So 1 means that we're just using the most frequent syntactic rule, 25 means we're using the 25 most frequent syntactic rules, and so on. So here's the classification accuracy on the Genia biomedical corpus using the syntax feature. And we see that there is some nominal improvement over baseline. So we go from 28% to something like 29% using the syntax feature. So the syntax feature does seem to have some useful information in it. So now let me go on to the second part, which is developing the new feature, syntactic recurrence for learning discourse solutions. So what does this mean? So in this feature, we leverage the temporal distribution of syntactic rules in a document. So if you think back to a syntactic rule like PP goes to prep NP, we can actually annotate a document for where that rule occurs. So in this case, that rule is used twice in the document, both times pretty close to the beginning of the document. And so we can measure that distance and normalize it, and so we have a relatively short syntactic recurrence. So the value for this feature is relatively low. You can also imagine another document where these rules occur at a greater distance. And so in this case, our syntactic recurrence feature value is going to be higher. So let's see how this feature does on the same task. This is again the biomedical discourse relation bank classifying into 31 classes. Here's our baseline syntax feature, and here are our results using syntactic recurrence. So we find about a 4% improvement over baseline, so this is substantially better than using just the syntax feature alone. And I can also talk about why this should be an interesting feature from a kind of linguistic and cognitive standpoint if anyone is interested in the question. So to summarize, we've provided the first evaluation of syntactic features for learning coherence relations in biomedical text. And we've also introduced a new feature, syntactic recurrence, that has not been tested anywhere before, that improves on that state-of-the-art. And we have plans to evaluate this as well on newspaper text and other genres to see what kinds of challenges might be unique to the biomedical genre. And we actually still have a lot of tricks up our sleeve for improving the feature. So if all goes well, we are hoping for an eventual submission to JBI. So thanks to my collaborators and funding agencies and to you. So accuracy is the percentage of correctly identified discourse relations out of that 31 set hierarchy. So that is on the lowest level. So there's 31 classes. But if we actually kind of back off to the higher level hierarchies, then that can go to like 12 or 4 classes. And so we're going to try that and expect higher accuracy there. And that might be enough to be useful for some applications.
And it was correctly detecting what of those modifiers were placed?
So it was not using the connectives at all. So we're using only the implicit relations. So we have clause 1, clause 2, and we want to identify that this is a contrasting relationship, this is a causal relationship, what have you. But it doesn't use any explicit connectives or do anything with that.
If you run on the biomedical, the articles in the database, like you can, and they already passed through an editorial phase where they actually made that good English sentences.
Yes.
I'm just wondering about like clinical notes, which sometimes don't have the same rigor of syntax and spelling, etc.
Yeah, so this is actually a notoriously difficult problem, even in polished editorial text. So kind of as a first pass, we're seeing what we can do in that genre. And then I think another logical next step is going to be what can we do with a genre like clinical notes, especially to address the challenges that Cece mentioned in the last talk. Thank you.